Okay, the goal of this video is to see if I can create a Python environment that uses GIS without actually using either QGIS, ArcPro, or GDAL. So what I mean by that is I'm looking at a GeoPackage that has a stream network vector layer in it. I want to be able to use Spatialite queries, so st underscore queries with that feature class without actually using GDAL, OGR, or installed desktop GIS. So what I'm going to do here is I'm going to go into CD code, Escapes. I'm going to make a directory for this called spatial demo code spatial demo. Okay, let's get rid of that. Okay, so here we are. Let's boost that up a bit. So first thing I'm going to do here is I'm actually going to initiate a virtual environment using UV. So where am I? I'm in spatial demo. So which Python? I'm using my pyenv environment, which is 3.12.9. So I'm going to create a UV environment. Okay, that's created that environment. And now I need a couple of packages in this. So I'm going to be UV add APSW. Okay, that is a SQLite wrapper that we're going to be using the Spatialite extension, and the regular SQLite Python package does not allow turning on of extensions or adding of extensions. I don't know if that's a security precaution, but this APSW is a wrapper around SQLite that does allow the enabling of extensions. Okay, think uh, I think that's all we need right now. So we'll do UV sync, and let's create a new folder in here called scripts. We're going to create a new file called demo.py. This is a Python file. And we're going to import argparse, and we're going to import this APSW. Def demo, and we're going to do def main down here, and we're going to do that right there. So this is helping me with the arguments. This isn't quite what I want, so I'm going to do spatial path. And this is the path to Spatialite library. And there's the DB. And so we're not going to do any of this in here. We're actually going to call demo. We're going to pass in the two things, and up here we're going to take these in. Take those. That looks pretty good. So what we actually need to do here is we need to create a connection to the database. So that's connecting to the database, and then on our connection, we need to first of all enable loading of extensions, and then we need to load the extension for Spatialite. get that cursor there, con, and then we'll come back here and we'll talk about this actual query here in a second. All right, so arg spatial path, argsdb, so that looks pretty good. Now, what we're actually going to do right now, we're going to try and run this file we're going to create a launch.json, the Python debugger, and it's going to be the active Python file. So that's given us a template. It's given us a template there. We're going to come back to demo. The next thing we actually need to do, you notice that it has actually detected the virtual environment. So that is the virtual environment that UV created. So we're actually going to just reload that window. And we're going to come in here, and this is not, what is that? That is the configurations. We're actually going to create a new one of these. We're going to call this one demo. Let's debug type. Program on this one is going to be demo. We need 2 args on this. I'm actually going to take these args from over here. The first thing we need is the Spatialite library. So I'm on a Mac and I have used Homebrew to install the Spatialite library. That's just brew install Spatialite, and that gets you this library of Spatialite capability. And the goal of this is to enhance our SQLite connection with that Spatialite code. And here is the file path to that GeoPackage that we were working with before. So what we can actually do now is we can, the query, let's just select star from network, limit 5, so that's just going to get us 5. Let's just see if for row in that, print the row. All right, so that should give us a functional script. Now we're not doing any GIS yet, we're just trying to actually run this guy. So no file. Okay, so spatial demo. Do we actually need? Do we actually need? Can't remember between module and that. So that is having trouble. Request program demo. To go terminal args. That all looks good. We can get rid of that. Let's just reload this guy. Oh, did I put this in the scripts folder? I did. Let's just move this out and put this back here. All right, we are in. And the first thing is that it's not finding that. this required business is not needed. Let's just take that off. Copilot. All right, we are successfully making a query into we're getting the top 5 records back from that table, and all this junk in here is the binary for the geometry of the shapes in the geom field. But the cool thing now that we can actually do is these are lines, so why don't we try to find out what the length of those lines is. Now, one important thing is that Spatialite uses the well-known text format for geometries, but GeoPackages use the OGR geometries, the OGR blob format of geometries. So we use this cast automagic to take the binary GeoPackage geometry, cast it back to the well-known text format, and then we can do normal Spatialite queries on it. So there we go. We have pulled back the top 5 records and calculated the length. Now this is in a projected coordinate system, so those are the lengths in meters of the top 5 records. We can do. I haven't tried this actually, but we can do that from network limit 5, and I think we have to do a group by. I think we have to do a group by on this. Does that have an FID? Yeah, so that is the union geometry. So why don't we do the ST length of that? I'm still getting 5 features there. Oh, that is limiting that. So I'd have to put this into a subquery, but now we're starting to chain together geospatial queries. So this is really powerful. Without QGIS, without ArcGIS, without GDAL, all I had to do was install Spatialite, a much lighter, easier to install library of geospatial code. I'm able to take a regular GeoPackage and perform GIS operations on it.